So rate of change. Okay, I'm going to ask volunteer to try to read this part. I hope you can read. Okay, Grant, can you read?
From where your finger is?
Yeah, from my here to
Definition of the rate of change. Y equals f of x if x changes from x sub 1 to x sub 2. So the increment of x is delta x equals x sub 2 minus x sub 1, and the corresponding change in y is delta y equals f of x sub 2 minus f of x sub 1. The difference quotient is delta y over delta x equals f of x sub 2 minus f x sub 1 over x sub 2 minus x sub 1 is called the average rate of change of y
with respect to
an x over x sub 1 x sub 2. Let x sub 2 go to x sub 1 or delta x go to 0. We get instantaneous rate of change, oh boy, equals the limits of
delta y over delta x.
Delta y over delta x as delta x goes to 0 equals the limit of x of f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1 as x sub 2 goes to x sub 1 at x equals x sub 1.
Great! You did great job! Okay, great job, okay? Very good.
I have no idea what I just said.
Well, it's hard, okay? It is really hard, okay? Well, say for example, we are having a graph for this function y equals f of x, okay? And then on the graph we have we have 2 points on it, okay? One point has x coordinate x1, the other point has x coordinate what? X of 2, okay? Of course we know that okay, the y coordinate for these 2 points are f of x2 and f of x1 respectively, okay? So this delta y over delta x actually give us what? Change in y. This part give us the delta y, okay, delta y, okay, and this give us what? Delta of x, okay. So delta y is a change in y divided by what? Change in x, which is f of x2 minus f of x1, okay. x2 minus x1 give us what? The delta of x, which is a change in x, okay. So this ratio, okay, or this different quotient is called what? Average rate of change, okay. Yeah, so this is the average rate of change. So when we talk about the rate of change, what is it? You know, it is what? It is a ratio, okay, about change in y divided by change in x, okay. Well, this is average rate of change, okay. Well, how about if we let this point, okay, the second point has coordinate x2, f of x2, okay, this point has coordinate x1, f of x1, okay. So how about we let this second point getting more and more closer to the first point, okay. That means x2 will be very, very close to x1, okay. So x2 approaches x1, or this delta x approaches to what? 0, okay. We'll have what? Instantaneous rate of change, okay. This is instantaneous rate of change, which is what? A limit when delta x approaches 0 of this rate of change, okay? And then if we write it down more specifically, it looks like this, okay? And then we call what? This is instant rate of change. And what is this, guys? What do you think about it? This instant rate of change actually is what? The derivative is also equal to the derivative of what? X, okay? When x equals what? x1. So what is instant rate of change? It is a derivative of the function x when x equals x1. Okay, so you know that, okay? You know rate of change is this, okay? Instantaneous rate of change is what? Derivative, okay? That gives us a derivative, okay? Guys, if we rewrite this function a little bit, okay, say this is what? This is the first point we record is this is x, okay. The second point, this is x, f of x, x, okay? And then the second one, we say this is x plus h, if this is h, not delta x anymore. So this will be f of x plus h. Okay, so we can actually rewrite this thing as what? F prime at when x equals x, limit what? F of x plus h, which is y value for the second point, minus f of x, which is y coordinate for the first point, and this x plus h, and divide by what? X plus h minus x give us what? H, when h approaches to what? 0, okay? So from this part, we can also derive the general definition for what? Derivative. So that's how we get what? The definition 2 on the next page, okay? It's still just using a different terminology, different notation, but you see, it's the same thing, okay? So this is still we get from the rate of change, instantaneous rate of change, we get what? The derivative, general definition for derivative of a function. Everybody, you see that? Okay, now let's try to practice something. Okay, try to practice something. Okay, this question is here. Okay, I hope you guys can see that. Okay, I hope so. Okay, this question is asking us, okay, to answer these questions, okay, from a given graph, okay, to estimate the values of each of these derivatives, then sketch the graph of f prime. Okay, f prime, okay, f prime is a derivative of f, okay. So let's try to answer this question first, and okay, how to find the value of f prime of -3 from this given graph? This graph is what? Y equals f of x, okay. So how can we find f prime of -3? What is geometric meaning of f prime of -3? Slope of the tangent line, right? Tangent to what? The curve. And at where? At the point -3 something, right? So -1, -2, -3. Oh, you guys really get it, okay? I'm so glad to hear that, okay? So this is when x equals -3, right? Okay, so this is a curve, okay? We're going to actually find what? The tangent line tangent to this curve at when x equals what? -3, right? So we actually f prime -3 give us the slope of this tangent line, right? And this tangent line tangent to this point -3, comma, blah blah. We don't know, okay? All right. So estimate the slope of the line. This line is decreasing, right? So the slope of the line has to be what? Negative. Okay, it's going to be a negative number. Do you see that? Okay, so how do we estimate this value? So it's going to be, if a -1, it looks like this, 45 degree, right? So it's not that steeper, right? So I would say a -0.2 or -0.3.
What was your line? You have the exact answer.
Yeah, okay. So it is here, okay? It is here, okay? The answer, I hide the answer, okay? Hold on 1 second, okay? But this is estimation, okay? Your estimation may be different, slightly different from the, exact answer, but it's an estimation. So we guess a -0.2, -0.3, okay? Hold on 1 second.
Yeah, it's
-0.2.
Yeah, these are the points, right? So it goes down one.
Uh-oh.
Exactly. Yeah, so it's -1.
Okay. There we go.
It's a little steeper than -3, exactly like that.
Ebook. Alright, so this is in section 2.7, practice. Alright. -0.2. Okay, -0.2. This is estimation, okay? Now let's go back to the question number B. F prime of -2. How about that?
Almost like a straight line.
Yeah, 0.2, okay, so this example of -0.2, okay? And then, so where is when x equals -2? This is the point when x equals -2, okay? So we're going to draw a tangent line to this point, right? What do you feel? When you have a horizontal line, slope is what? 0. Okay, very good. So f prime of negative 2 give us 0 value. Okay. Then I'm going to try f prime of negative 1. Okay, f prime of negative 1, so when x equals negative 1, this is a point on the curve, but we're going to draw tangent line to it and then find the slope. What do you feel? It's more like 45 degree, right? We would guess 1, possibly 1, right? It's a guess, okay, it's a guess, estimation, okay? So how about the f prime of 0? Looks like this, right? It's going to be a number greater than 1, right? So let's guess a 2 or 3. Yeah, it's a guessing, okay? So let's guess it's 2, okay? And then we do f prime of what? 1. Okay, x equals 1. So I would say what? A 1, right? Slope is 1. Yeah, right? Less than 1. So give me a number.
0.75.
Oh, 0.75. Okay. It's the estimation. We'll check the answer, okay? The estimation. F prime of 2, 0. Okay, because it's going to be what? A horizontal line. And F prime of 3 is going to be what? I would say negative 0.2. Okay? Alright, so let's check the answer quickly. 0, we're right. 1 and 2, you can get a 2.5 or 3. It's just estimation. A 1, okay, so just now Simon guessed the 0.75 is close to 1, okay. Well, f of 2, 0 is 0, and f prime of 3 is negative 0.2, right, okay. So what is the idea? Why I'm putting this practice question here in our practice problem? Because I want you guys to really understand the geometrical meaning for what? The derivative, okay? So this f prime of, at a number actually give us what? Slope of the tangent line, okay? And then this tangent line is tangent to the curve at when x equals these values, okay? All right, we're not done yet. Sketch the graph of f prime of f prime, okay? So how do you sketch the graph for the f prime? This is when x equals negative 3, f prime equals negative 0.2, right? So if we're going to draw a picture, it's going to be, okay. So 0, negative 1, negative 2, negative 3, 1, 2, and 3, okay? So when x equals negative 3, f prime, this is f prime, okay? It's not f, it's f prime. So x equals negative 3, f prime equals what? Negative 0.2, okay? So it is going to be slightly lower than the x-axis, key point. Well, x equals negative 2, f prime equals what? 0, key point, do you see that? X equals negative 1, f prime equals what? 1, a point here. F of 0, f prime of 0, okay, when x equals 0, f prime equals what? About 2, right? 2, 1 and 2, okay? And then we see x equals 1, f prime equals what? A 1, what's up?
How are the slope of the derivative of negative 1 and derivative of 1 different?
It should be the same.
It should be the same.
Because this is a guessing estimation from Simon. It is 1, okay, it is 1, okay? Alright, and then f prime of 2 is 0, and then negative 0.2. So if we draw the picture, yeah, it's a bell-shaped symmetric curve. Okay, so there are some other practice questions from the book. Okay, well, this is question 1 from the section 2.7. The second question, okay, from the, from here, it's the same thing, okay? So I want you to practice this question by yourself if we have time, okay? If we don't have time, you can practice at home, okay? So try to find these specific values and then draw the what? Derivative. See, the original picture and then the derivative, they may look totally different. okay? They may look different. So this is original graph, okay? So you're gonna estimate, look at those slopes and then find those f prime values and then draw the graph for f prime by yourself, okay? Okay. All right. So in class we'll only have time probably just do one problem, okay? But you know that, okay? You know this. All right. So this is a practice question, okay? And then the other question on this page is to what? Use definition to find what? The derivative of the function, okay? So far, we haven't learned any rules, okay, to compute derivative, okay? In chapter 3, we'll focus on what? Develop those rules, okay? So later in chapter 3, after you learn chapter 3, you'll see we don't have to use definition every time, okay? But so far, we don't have any choice, okay? So our only choice is to use what? This to compute what? The derivative of a function, okay? And in your exam 2, I might give you a question, okay, about what? Use a definition to find the derivative of a function. Then what are you going to do? Use a definition, okay? If you use a rule, okay, so look at the requirement of the question, okay? If I say, please use a definition of the derivative to find the derivative of a function, then we're going to use what? The limit to find out the derivative of the function, okay? All right, so let's try this question together, okay? This is not easy question, okay? It needs a lot of calculation, okay? So find f prime if f of x is defined like this. Let's see how. Compute f prime of x by using definition. What is the definition? H approaches to 0. What? You remember? F of x plus h minus what? F of x and divide by what? H. Right? This is definition, right? So what do we do next? Plug in definition, okay? So equals, I want to leave myself enough space because there will be a lot of calculation, okay? What is x plus h? Replace every x in this function by x plus h. So it is going to be 1 minus parentheses x plus h. You don't want to mess up with a sign, okay? If we do not put a parenthesis, that will be different, okay? So if we don't put a parenthesis, it becomes 1 minus x plus h. Well, it's not. It should be 1 minus parenthesis x plus h. Same thing on the bottom, 2 plus x plus h. Later, we get rid of the parenthesis, okay? But when we plug in at the first place, we don't, we have to keep the parenthesis. Minus f of x. What is f of x? This. 1 minus x divided by 2 plus x divided by what? H. Right? And then let's see, how can we simplify this whole expression? On the top, we have two fractions. Can we combine the two fractions? What is the least common denominator for them? The product of these two denominators, right? So, what is it? I would say, I'm combining them, okay? So one is,
Professor,
what's up?
before we do that, can you actually put the h inside those fractions? When you're dividing by h, so you can say 1 minus x plus h over h times 2 plus x plus h.
Divide by...
Put the h in the other fraction as well. It just looks simpler.
Okay, so you want to divide by this h?
I'm just saying put h on the bottom of both fractions.
Yeah.
Because you can split them apart.
Yeah. Okay, so now we are combining this, right? Combining later, okay, in the next step, okay, I'll write that, okay? So 2 plus x plus h times by what? 2 plus x. This is a least common denominator, right? So how do we do with the numerators? Let this numerator, which is 1 minus x plus h, times by what? 2 plus x, right? And minus what? 1 minus x times by what? This, right? Ooh, that's a lot. And then divide by what? H at this point. I'm going to slow down a little bit until everybody can follow me, okay? Are we on the same page, everybody? Alright, so limit h approaches 0. Ooh, that's a lot, okay? This denominator divide by h. So I'm going to put these two together, okay? This part and h together, okay? So give us h times by 2 plus x plus h, bracket times by 2 plus x, right? And now we have to simplify the numerator. That's a lot, okay, the numerator. So how? I would use 2 plus h to distribute, okay, and later use this to distribute. Okay, so 1 times by 2 plus x give us 2 plus x minus what? X plus h times by 2 plus x. See here, careful. Negative 1 minus x times by 2. Negative 2 times by 1 minus x. Negative 1 minus x times by x plus h. Yeah, please make sure you're good for this line. Now we're going to simplify, okay? I say these two terms, they are like terms. Why they're like terms? Because for these two terms, both of them have a what? Negative x plus h as a factor. Do you see that? And then these two terms, I will simplify them directly, okay, directly, okay? So let's see. Limit h approaches to 0. Okay, let's see, okay? 2 plus x minus 2 plus 2x. So for the constant part, we have a 2, we have a negative 2, so that's gone, right? Offset. Am I doing too fast?
Wouldn't it be the negative 2 multiplies into the negative x, so wouldn't that be positive and you get a positive 2x?
Yeah, that's going to be positive 2x. And that positive 2x plus this x give us what? 3x. You're right. But this negative 2 and this positive 2 offset, they're gone. So, guys, do you see that? After we combining these two, we'll only have a positive 3x left. Do everybody see that? I'm skipping some step. Negative 2 times 1, negative 2, positive 2, gone. Negative 2 times negative x give us positive 2x plus x, 3x. Okay? Now let's check these two terms. Every term has a negative x plus h. Negative x plus h. I'm going to pull the negative x plus h out. So minus x plus h. Okay? And what does this term left? What have left from this term, this product? 2 plus x, right? And if we pull the negative x plus h out, we'll have what? 1 minus x left. So plus 1 minus x. Ooh, I think this is too hard, right? Negative x plus h out. 2 plus x is left over. 1 minus x is left over. Okay? And then what do we have here? X, negative x gone. So actually we have a 3 times by this thing, right? So let's leave this in the next step. H times by parenthesis, bracket 2 plus x plus h times by 2 plus x. Let's see on the top. 2 plus 1 give us 3, right? So this is 3x minus 3x plus h, right? Divide by whatever, blah, blah, okay. equals limit h equals to 0, 3x minus 3x, gone. Negative 3 times h, we should have what? Negative 3h on top. You see that? Okay, and we have h times by 2 plus x plus h bracket 2 plus x, right? And then this top and bottom have a factor h, right? So negative 3 divided by this. When h approaches 0, what can we have? When h approaches 0, okay, we should have a 2 plus x in this bracket. We have a 2 plus x in that parenthesis. So actually, what do we have on the bottom? 2 plus x squared. On the top, we have what? A negative 3. See? There's no h anymore. And then we have x left. And later, after we learn in chapter 3 about use quotient rule to do the calculation, it will be much easier than the definition method. And you can check, we're going to still get the same answer. Okay, but so far we are practicing by using definition. It's more tedious, right? So I would strongly suggest you write that formula definition on your formula sheet and apply it if possible. Okay, yeah, if needed. Okay. All right, so this is page 2. Okay, page 2. Okay. All right, we have the last part. We still have one more. Okay. Well, this page 3 is just what? It's just a notation. Okay, it's just a notation. Okay, I will read through this notation quickly. Okay, and then we'll practice. Okay. So remark. If y equals f of is a function of x, then some alternate notations for the derivatives are as follows, okay? So we can use f prime of x, or y prime, we'll use dy over dx, we'll use df over dx, we'll use d of f of x over dx, or d of f of x, or d of f of x, x, okay? So all of these notation looks quite different. They all represent what? The first derivative of what? Function f with respect to x, okay? And then the value of a derivative at number a, okay, usually we write it, we use a vertical line, okay, saying, okay, at x equals a, okay, yeah, this gives us the value, okay, because dy dx, okay, only give us what? A function of x, okay, because f prime of x gives us a function of x. In order to find the value of the derivative at number a, we have to write it as x equals a, okay, or it's the same thing as f prime of what? A, okay. So this and that, they are the same thing, okay, they are the same thing. So these are the alternate notations for the derivatives of a function, first order derivative, okay. Well, the other remark is telling us higher order derivatives, okay? So if f is differentiable, means what? We are able to find the derivative of f, so that's called a differentiable. Then the second derivative we call f prime prime. It is defined by what? The prime, the derivative of what? The first order of the derivative, okay? So we find the first order derivative of f, then we do another derivative. It gives us a second order, okay? Third derivative is we find the derivative from the second order. Nth order is from what? F by differentiate f n times, okay? And then Leibniz notation, okay? Y equals f of x, okay? Second order derivative, okay? Y prime prime is by what? Yeah, this is a Leibniz notation, okay, for first order, okay? Second order derivative is what? Differentiate of dy over dx with respect to dx, with respect to x, okay? Or we can write it as what? D square y dx square, okay? Looks square, it's not square, okay? So here pay attention to the notation. This is a differentiate y with respect to x 2 times, but we put this, this 2 on top is between d and y, okay? but not between, okay? This is on the top right of D, but here we write this, the 2 on the top right of X, okay? So this is a difference, okay? Okay? And then,
You wouldn't actually get the right answer if you squared the function and divided it by another square, would you?
no, this is a means derivative. It doesn't mean square. It's not square. I shouldn't say square. It's a second order derivative. Means differentiate the function f 2 times.
I thought so, it's just weird.
Yeah, it looks, but you have to know that's derivative, okay? Star derivative is differentiate the result from the second order derivative, okay? Where we write d3y, okay, dx to the, yeah, looks like this, okay? Nth order is dnth y divided by dx to the nth power, okay? Well, not nth power, dxn, okay? And then also we can write as fnx, okay? Alright, so these are just the notations, okay? I want you guys to really, read them again and then digest, okay?